Next topic, binding energy curve. So here we are calculating the average binding energy per nucleon. What is the meaning for average binding energy per nucleon? The average binding energy per nucleon is the energy required to separate single nucleon from the particular nucleus. Okay, so the energy required to separate a single nucleon from the particular nucleus is called average binding energy. So in a formula, the average binding energy it can be written as Be bar is equal to ZMH plus NMN minus MA C square. This is a equation for the binding energy divided by A. Okay, so A is a mass number. So the average binding energy per nucleon is the energy required to separate a single nucleon from the particular nucleus. So here we are taking the average binding energy against the mass number of all known nuclei. So we get the average binding energy curve. For this, the average binding energy is taken in y-axis. The number of nucleons, that is a mass number, is taking in x-axis, and draw the graph between the average binding energy per nucleon and the mass number, that is number of nucleons of the known nuclei. So from this graph we are going to discuss the important interference of the average binding energy curve. So the value of the average binding energy rises and the mass number increases. As the mass number is increases 50, 100, 150, 200. When the mass number is increases, the average binding energy is also increases. The average binding energy is also increases. It is reaches to maximum value of 8.8 electron volt. Okay, there is 8.8 mega electron volt. Average binding energy is equivalent to mega electron volt. It is reached to maximum values at 8.8 mega electron volt for mass number A is equal to 56. For 56, it is reached to maximum values. The mass number is 56. That is for ion. Okay, and then it is slowly decreases. Next point, the average binding energy per nucleon is about 8.5 mega electron volt. Okay, it is about 8.5 mega electron volt for the nuclei having mass number lying between the 40 to 120. It is lies between the values is 8.5 mega electron volt. Okay, so the average binding energy per nucleon is about 8.5 mega electron volt, 8.5 mega electron volt for the nuclei having mass number lies between the 40 to 120. These elements are more stable and not radioactive. Okay, these elements here strontium, like this, some of the elements is also given. Okay, so here these elements are stable and not radioactive. Next point, for higher mass number, the curve drops slowly. The mass number is greater than 150. Okay, for the higher mass number, the average binding energy per nucleon curve is drop slowly, and the average binding energy per nucleon for uranium is about 7.6 mega electron volt. Is about 7.6 mega electron volt. Such nuclei are unstable and radioactive. Okay, so the uranium is another unstable nuclei and radioactive nuclei. So from the diagram, if two nuclei, that is a lighter nuclei, it has a mass number is less than 28. It has a mass number less than 28. It is hydrogen, helium, like this. It has a mass number less than 28. Combined with the nucleus with mass number is less than 56. Okay, the smaller nuclei is combined with the another nuclei. It has a mass number is less than the 56. So the binding energy per nucleon is more for final nucleus than the initial nuclei. Okay, thus if the lighter element combine to produce a nucleus of the medium value A large amount of energy will be released. This is a basis of nuclear fusion and it is the principle of the hydrogen bomb. Okay, when the two lighter nuclei is combined and it is form the another nuclei, it has a mass number is greater, but that mass number is less than the 56 bits. Here it is also releasing the large amount of energy. So this is a basis of the nuclear fusion and it is the principle of the hydrogen bomb. Like this, here if a nucleus of heavy element is split into 2 or more nuclei of medium value A. Okay, the heavier nuclei is split into 2 or more nuclei of the medium value mass number A. The energy released would again to be large. So this is also principle for the atom bomb. Okay, that is a nuclear fission. The nuclear fission is one of the principle for the atom bomb. Here this type of reaction is one of the uncontrolled reaction. The atom bomb comes from the fission when it is uncontrolled. So it is also one of the uncontrolled chain reaction. Okay students, thank you.